Hi everybody, we are back and we are doing section 10.3, volume of pyramids and cones. So in this section, our objective is just to be able to calculate the volume of a pyramid or a cone. Each one of those has a unique formula. They are very similar, it's just that a pyramid has a polygon base and a cone has a round circular base. So here we go. There is a special relationship between the volumes of prisms and pyramids that have congruent bases and the same height. And that relationship is that one prism is equal to 3 pyramids if they have the same base and the same height. So here you can see we've got one rectangular prism. If I were to take that same the rectangular base and make a pyramid out of it, 3 of those pyramids together is going to equal the full volume of the prism itself. Now you can work in reverse and say that a pyramid is 1/3 of the volume of the prism. That's the same as multiplying by 3 or dividing by 3. But 3 pyramids add up to 1 prism, but they have to have the same bottom shape and the exact same height. All right, so here are some examples. And this one you can see has a rectangular base, and it's a prism versus a pyramid, but they both have a base that's 4 by 4, and then they both have a height of 10. So in this case, we would do area of base times height. Now, because the base is a rectangle here, our formula would be the base and the height of the rectangle. So this would be little base and little height. So we would do 4 times 4 for the area of the base, and then multiply by how tall it is, which is a height of 10. So 4 times 4 is 16 times 10 is 160. Now this didn't have any units, so I'm going to say units cubed for the volume, because the volume is cubic units, 3-dimensional. All right, let's do the same thing over here, but when we have the pyramid, I'm going to do the exact same formula as we did for the prism, base times height, except since 3 of these pyramids fit into the prism, I'm going to chop this into 3 equal parts. So here I'm going to do 4 times 4 because that's the base and height for our base area, multiply by 10 for the height, and then chop it into 3 equal parts because we're only finding 1 pyramid. Now I can't do that part in my head. So 4 times 4 is still 16, times 100 is still 160, but I need to chop it into 3 equal parts. So the volume of this one particular pyramid is approximately 53.3 units cubed. So basically all I have to do is find the formula for the prism that matches it and then chop it into 3 equal parts. Okay, for a triangular prism and a triangular pyramid, note that these don't have numbers involved, and so we're just going to write the formula for these. So the formula for a triangular prism volume would be base times height divided by 2, because that's the area of the base, and then we'd multiply by how tall it is. Now, triangular pyramid, it's going to be the same formula, base times height divided by 2 times height. Shift that over. But because it's a pyramid, it is 1/3 of the size of the prism. So we'll divide by 3. Now your little b and little h, those represent the base and the height of the triangle itself. So it kind of depends on what triangle you have at the bottom. If it's a right triangle, obtuse, or acute, on which parts you're going to need. Okay, a trapezoid has a little bit more complex area formula. So remember, all of these are area of the base times the height for the prisms, but this base value is dependent on the shape of the bottom. So here we have a trapezoid. And we have base 1. This base 2 is actually repeated down here. And then we have the height of the trapezoid. So in place of this capital B, we're going to do base 1 plus base 2 times height divided by 2. That's because it's a trapezoid. And then we'll multiply by the capital H, the height of the prism. So for our pyramid, we have this whole formula again, but then we divide by 3. So base 1 plus base 2 times height divided by 2 times our big height, how tall it is, and then divide by 3. All right, a regular polygon, again, has a unique formula for the base. So volume is area of the base times the height. Remember, the height is up and down connecting the two bases. And then because this guy down here happens to be a pentagon, we need to use the regular polygon formula for the area. So I would replace this guy with side length times apothem divided by 2 times number of sides. That's going to be equivalent to the area of the base, and then we multiply it by the height. For the pyramid, we're going to do this exact same formula, but just chop it into 3 equal parts. Okay, so I'm just going to recap quick. You can see with all of these formulas for pyramids, the prism is the same formula. We're just chopping it into 3 parts to make the pyramid, but all of the formulas are area of the base times the height, or area of the base times the height divided by 3. And so you just have to figure out what is that base shape so that you can figure out the formula. And I've kind of broken it down. If the base is a triangle, you'll use these ones. If it's a trapezoid, use these ones. If it's a regular polygon, use these ones. And then the rectangle square would be that first example. Okay, a cylinder and a cone have that same special relationship. But again, it has to be if the cylinder and the cone have congruent bases and the same height. So this base down here is the exact same area as this base here, and the height is the same as the height here. And again, one cylinder is the same as 3 cones. So a cone is 1/3 the size of the cylinder. All right, now because a cone and a cylinder don't have different base shapes, there's only one formula that we're going to use. So when we're finding the volume of a cylinder, we have the base of the shape first, area of the base times the height. But because that base is a circle, we're going to take that capital B out and replace it with the formula for a circle, which is pi times radius squared. And then the height is how tall that cylinder is. Now for the cone, it's going to be the exact same formula, but 1/3 the size. So volume is pi times radius squared times the height divided by 3. Now on a cone, we do have a slanted side, so make sure that your height is the straight up and down. Remember that slanted side is represented by a L for slant height. We're not using that in the volume formula. We only use that in the surface area formula. All right, let's do a couple examples. Excuse me. First one says, find the volume of a regular hexagonal pyramid. Okay, so regular hexagonal pyramid. I'm first going to reference back to that formula. A regular polygonal pyramid, volume is going to be side length times apothem divided by 2 times number of sides. Remember that is the area of the base. And we're going to multiply by the height and then divide by 3. Okay, so now I just got to plug in all the values. So this right here, that's our side length, 6. This value here, that's our height. That'll be an 8. And then we still have divide by 3, this divide by 2 in here. So I just need to figure out what is my apothem and how many sides do I have. So counting 1, 2, 3, 4, 5, 6. This is a hexagon, so this would be 6 sides. And then I believe up in the question they told us our apothem is 5. All right, now I just need to use my calculator to find out what does this equal. Okay, 6 times 5 divided by 2 times 6 equals. So the area of the base is 90. Still going to multiply by 8, and I'm still going to divide by 3. Times 8 divided by 3. So this volume equals 240 centimeters cubed. Okay, this question is very tricky because they're asking us to find the height if the volume of the cone is given. So we're actually working backwards. So what I'm going to do is I'm going to do the formula for a cone, which is pi times radius squared times height divided by 3. And we're just going to plug in everything we know, just like we did on this last equation. Separate that out. Okay, so I know pi is just pi. Now, if we want to keep it as a pi, we can. You can also change it to 3.14. But up in the problem here, the volume that they gave us also has a pi in it. And so those are going to cancel out really nicely with our t-chart. Okay, so looking down here, I can see my radius is 3. The height is what we were trying to find, and the height. So I have to leave that as an h. But divide by 3 is still part of the formula. And then up at the top, it said that our volume was 24 pi inches cubed. So over here, instead of V, I can put 24 pi. And then we're going to do a t-chart. Now again, like I said, because there's pi's on both sides and it's all multiply or divide problems, we can just cancel them out. And then we're just going to undo the operations. So opposite of divide by 3 would be to times, oops, that's a 9, not a 3. And then these would cancel. 24 divided by 3 comes out to be 8. Okay, now I know what 3 squared is. 3 squared is 3 times 3, which is 9. So I'm just going to change that. And then we're still trying to figure out our h. All right, next step. We're going to get rid of this times 9. So we're going to divide by 9. Oh, you guys, I screwed this up. Back the train up. Oh, too far, too far. All right, 24 times 3 is what we have to do first. 24 times 3 is 72. And I know 3 squared is 3 times 3, which is 9. And we're still multiplying by our height. So now I just need to figure out how do I get rid of this 9. It's being multiplied, so the opposite is to divide. 72 divided by 9 is 8. So that means my height is 8 inches. All right, question 3. Find the volume of the square-based pyramid. Now, because it said square-based, I know that all these sides are the same length. And because it's a pyramid, I know I'm going to end up dividing by 3. So area of the base times the height divided by 3. Now, being that this base is a square, I need base times height, which would be 10 times 10. And then I'm going to multiply by the height of the pyramid itself, which is 12, and then divide by 3. So 10 times 10 times 12 divided by 3. My volume comes out to be 400 centimeters cubed. Now over on the right, we have another pyramid. This time it has a rectangular base, but they give us the volume and they want us to work back to find the missing height. So volume equals area of the base times the height divided by 3. The volume in this case is 112. The B, capital B, is little base times little height, 8 times 7, multiply by our missing height, and divide by 3. So I'm going to do some simplifying before I do my t-chart. I know that 8 times 7 is 56. And now I'm going to solve with a t-chart. Opposite of divide by 3 would be to multiply both sides by 3. 112 times 3. That is not right. 112 times 3. Yep, 336. And that leaves us with 56 times h. These will disappear. Opposite of multiply is to divide. (336) divided by 56. I get a height of 6. What was the label on this again? Inches. So 6 inches is our height. Okay, find the approximate radius of the cone if the volume is, last problem. Awesome. All right, so we're looking for the radius, which is our missing r value. They give us the volume here. So volume of a cone formula is pi times radius squared times height divided by 3. In this case, volume is going to be plugged in as 33.5. Pi, because there's no pi in the number here, I'm going to change that to 3.14, just so I have an easier number to work with. My radius is what's missing, so r squared stays in r squared. My height is how tall it is, which in this case is 8 inches, divided by 3 because it's a cone. Now we're just going to do a t-chart. Opposite of divide by 3 is multiply by 3. That comes out to 100.5. Now I'm going to get rid of this times 8. I'm going to divide both sides by 8. Not a very pleasant number, but I'll write down all the digits that I have. Okay, now I got to get rid of the pi first. So this 3.14 is being multiplied. So the opposite of multiply would be to divide by 3.14. And it comes out to almost exactly 4. And then we just have to get rid of the squared next to the r. An opposite of squaring is a square root. So r equals 2. So in this case, our radius is a length of 2 inches. Great. Thanks, everybody.